Most students learn calculus as two warring kingdoms. Kingdom 1 is the derivative, the exact slope of a curve at one precise moment. Kingdom 2 is the integral, the messy area trapped under a curve. One is about motion and division. The other is about addition and static shapes. They feel completely unrelated, but deep inside mathematics, a single bridge connects them. The bridge reveals something almost unbelievable. Area becomes slope. To see this magic, stop seeing area as frozen geometry. Instead, imagine the right boundary as a moving wall. As the wall slides forward, the trapped area grows. This turns a static area into a living, growing function called a of x. Now zoom in macro style. Nudge the moving wall forward by a microscopic step called dx. This adds a tiny vertical sliver of new area to the total. Because the step is so unimaginably narrow, the curved top of the sliver becomes perfectly flat. It is a perfect rectangle. The width is our tiny step dx. The height is the value of the function at that exact spot, f of x. So the new sliver of area, called dA, is height times width. Now do basic algebra. Divide both sides by dx. You get dA over dx equals f of x. But wait, a change in output over a change in input is the exact definition of a derivative. The rate at which area grows equals the height of the original curve. Think about a car on a highway. The height of the curve is your current speed. The total area accumulating under the curve is the total distance you have driven. If you measure how fast your total distance grows at any single second, what do you get? Your exact speed. Rate of accumulation equals the height. This flips how we solve math. To find the area under a curve, you do not sum billions of tiny rectangles. You work backward. You find a function whose derivative matches the curve. Take this curve. F of x equals 8x minus x squared. To find the area function, we use the reverse power rule. Pause the video right now and see if you can guess the equation that differentiates into this curve. The answer is 4x squared minus 1/3 x cubed. This single formula is a superpower. It tracks the accumulation of area across the entire graph. To find the exact area trapped between starting line A and finish line B, you do not care about the middle. You only look at the boundaries. Calculate the antiderivative at the final point B and subtract its value at the starting point A. You bypass the infinite complexity of the middle. This master key is the Fundamental Theorem of Calculus. It proves that integration and differentiation are perfect inverse operations, like multiplication and division. One tracks how a total grows. The other measures the speed of that growth. They perfectly undo each other. If calculus finally makes intuitive sense, hit that subscribe button. In the next video, we visually unpack Taylor series. See you there!